Chapter 3, Triangles. 3.1, Introduction to Triangles and the Triangle Angle Sum. Well, real quick recap, a triangle is a polygon with three sides. The sides of a triangle are line segments, and the corners, or vertices, form the angles on the inside of a triangle. So we take a look at this real quick. One thing that's going to become really important later on in this course is to be able to identify. This is side 1 over here that I'm going to highlight yellow. It's really important to be able to identify what side is across from, meaning if you go through the center of the triangle, what angle. That's why you see angle 1 is labeled in the bottom left corner, and that's across from side 1, and so on. Side 2 is across from side angle 2, and side 3 is across from angle 3. Now, there are different ways that you can classify a triangle by its sides. A scalene triangle has no congruent sides. An isosceles triangle has exactly 2 congruent sides. And an equilateral triangle has 3 congruent sides. To classify it by its angles, an acute triangle is where every single angle is less than 90 degrees. A right triangle is an angle that has one right angle in it. It can't have more than one, and we'll find out soon why that is the case. An obtuse triangle has one obtuse angle. So right here we see that this angle is bigger than 90 degrees. So that's what makes that an obtuse triangle. An equiangular triangle is an angle where a triangle where all 3 angles are congruent. And turns out that in an equiangular triangle, every single angle will always be 60 degrees. It doesn't matter how large or small the triangle is, that statement will always be true. And we're going to find out why very soon. But more importantly, if a triangle is equiangular, it automatically has to be equilateral. Or vice versa. If you know it's equilateral, it has to be equiangular. So if a triangle has 3 equal sides, it has 3 equal angles. If a triangle has 3 equal angles, then it has 3 equal sides. So we're going to classify these triangles by sides and angles. Well, first of all, there are no side markings. I don't know that any 3 sides are congruent, which means it's scalene. And this angle here looks bigger than 90, which would make it obtuse. So this is an obtuse scalene triangle. B. It has 2 equal sides, which means it's isosceles. And it looks like that angle is less than 90, that angle is less than 90, and that angle is less than 90. So that means all 3 angles are less than 90, which means it's acute. And it's an acute isosceles triangle. This one, I see that all 3 angles are equal, so I know it's equiangular. And we did say that if it's equiangular, it automatically must be equilateral as well. So I'm allowed to add those tick marks in this case. I couldn't add them in A because I didn't have enough information to really add stuff to the diagram. But since all 3 angles are equal, that means all 3 sides have to be equal as well. So I'm allowed to add those marks. So it is equilateral and equiangular, which, if we remember from a previous unit, that makes it a regular triangle. If a polygon is both equilateral and equiangular, it is a regular figure. Now, let's talk about angles and triangles. In the diagram on the right, the orange angles, 1, 2, and 3, are all on the inside of a triangle. We refer to those as the interior angles. They're the angles in the corners and the vertices of a triangle. But imagine at each vertex, what if you extended the line of the triangle a little bit? Then you would form these exterior angles here, here, and here. Those are called exterior angles. And again, they took, for example, this line right here, and they just stretched it out. They took this side of this triangle and they stretched it out, and so on, to form those exterior angles. Well, The triangle angle sum. Turns out that the sum of the measures of interior angles in a triangle will always add up to 180 degrees. So look at this triangle. That is a triangle. Angles A, B, and C are all interior angles. Therefore, the measure of A plus the measure of B plus the measure of C has to equal 180 degrees. And that's why we said earlier, if it's equiangular, all the angles are equal, they will always be 60 degrees, because 60 plus 60 plus 60 equals 180. What about exterior angles? Well, there is an exterior angle theorem. And now the word theorem just means a statement that has been proven true using logical reasoning. It turns out that the measure of the exterior angle, so angle 1 in this diagram is an exterior angle. The green, red, and yellow angles are all interior angles. The blue angle, angle 1, is an exterior angle. Now, the way the exterior angles work is that the measure of an exterior angle of a triangle is equal to the sum, which means you add together, of the measures of the two non-adjacent interior angles. So you add together the two angles on the interior of a triangle that's not attached to the exterior angle. So I'm looking at this diagram. What is attached to the blue angle? The yellow one. So I don't want to use that. The exterior angle is equal to the sum of the two non-adjacent, meaning angle A and angle B. Because A is not attached to the exterior angle and neither is B. All right, let's try out a few problems. Find the value of x. Okay, well, it's important that as we get into more and more complicated diagrams, we want to really ask ourselves, well, what is x a part of? Is it a part of an angle? Is it a part of the side? Where is it? What type of figure is it attached to? In this, x is an angle, clearly because it has a degree symbol, but it's also the interior angle in a triangle. What do we know about the interior angles of a triangle? Well, the interior angles of a triangle add up to 180. So that means the x plus the 61 plus the 40 has to equal 180. Why? They're all interior angles of a triangle, and the interior angle sum of any triangle is always 180 degrees. Now, again, the order doesn't matter. I did x plus 61 plus 40. You could have done, x plus 40 plus 61, 40 plus x plus... It really doesn't matter. The order doesn't matter on the left, okay? So now what we're going to do is we're going to combine our like terms on the left, the 61 and the 40. I can add those together. And then next step to solve this equation, all I need to do is subtract both sides by 101. And I found that x has to be 79. Next problem. Common mistake on a problem like this. It's very tempting to do this. This would not be correct. That is incorrect. Why? Because remember, all three angles add up to 180. And remember, that box means what? That box means 90. We can't forget the right angle. Now, a shortcut, if you want to use it, in a right triangle, what if you subtract 180 minus 90? You're left with 90. So that means the two acute angles, the x and 30, add up to 90. It's up to you if you want to use that shortcut. It'll save you some time and effort. But if you feel like you're going to forget when you can do that, you can always rely on, interior angles, add them all together and set it equal to 180. You should still get the same answer in the end. So I'm going to combine my like terms over here. I've got the 30 and 90 on the same side, so I can just add them together. And next, to solve, all I need to do is subtract 120 from both sides. And I get that x equals 60. Next problem. Okay, these are all angles on the inside of a triangle. Well, the inside angles of a triangle, the interior angle sum, is always 180. So I know it looks like a lot. I know we got a 6x minus 8 and x plus 4. Oh no, this looks complicated. Nope, just take a deep breath. They're angles on the inside of a triangle, right? And we do know that the angles on the inside of a triangle add up to 180, right? And it doesn't matter what order we do it in. I'm just writing this out like this so you can just get a visual. Remember, the angles add up to 180. So fill it in. How much is the red angle? X. Plus, how much is the blue angle? 6x minus 8. Plus, how much is the green angle? X plus 4. Now, it really doesn't matter what order you do that on the left. You should get the same answer in the end. Let's combine our like terms. X, 6x, and x. That will give me 8x. I have negative 8 and positive 4, which will give me negative 4. Add 4 to both sides. And I get 8x equals 184. And last step, all I need to do is divide both sides by 8. And I get that x equals 23. All right, example 3, find the value of x. Okay, well, we need to figure out where x is. Is it located on the inside or is it located on the outside of this figure? Well, x in this case is an exterior angle in this triangle. I also have an interior angle here and an interior angle here that are non-adjacent angles. Well, the way that an exterior angle works is the exterior angle will always equal the sum of the two non-adjacent interior angles. So x is going to be nothing more than 80 and 60 added together. That's it. So just be careful. Don't just get it in your head because it's a triangle. Oh, I need to set everything equal to 180. That's not true. You'll get yourself into some trouble and have some wrong answers if you always assume, hey, it's a triangle, set it equal to 180. Triangle, 180. Nope, that's not true. Interior angle sum equals 180. Next problem. I once again have an exterior angle. And I have two non-adjacent interior angles located here and here. Now, it really doesn't matter if we do red plus blue or blue plus red. That's irrelevant as long as it's the outside angle equals the sum of the two interior angles that is not attached to, the non-adjacent interior angles. So the exterior angle is the 3x plus 6 equals x, the red angle, plus 80, the blue angle. So there's my setup for that one. So to solve this, I can start off by subtracting x from both sides. And that'll give me 2x plus 6 equals 80. I can subtract 6 from both sides. I'll get 2x equals 74. And last step, all I need to do is divide both sides by 2. And if I do that, I'll get x equals 37. At this point, I'd like you to pause the video and try out all the problems under example 4 on your own. When you're ready, unpause the video and you can check your answers. First problem, I've got interior angles. The interior angle sum of a triangle is always 180. So all I need to do in any order, again, I wrote 52 plus 43. You don't have to write it exactly in that order because we should still get the same answer in the end. When we combine our like terms, we get x plus 95 equals 180. Then all I need to do is subtract 95 from both sides, and x equals 85 for the first diagram. Next, I have another interior angle sum problem. The x plus the 2x plus the 3x must equal 180. Those are all angles on the inside of a triangle. If I add the x plus 2x plus 3x, that'll give me 6x. Last step, all I need to do is divide both sides by 6. This problem is an exterior angle. The exterior angle equals the sum of the interior angles that it's non-adjacent to. So all I need to do to figure out x is add together 21 plus 34. And I get x equals 55. Now again, you don't always involve 180. That's only for interior angles. X is an exterior angle. What about the next problem? Well, interior angles, the 3x minus 1, plus the next angle, 31. Don't forget the last one, plus 90, has to equal 180. I've got some like terms I can combine on the left over there. We can add the -1, the 31, and the 90 to get 3x plus 120 equals 180. I'm going to subtract 120 from both sides. I'm out of space, so I'm actually not going to write that step down. But the next thing I'm doing is I'm subtracting 120 from both sides. So I'm left with 3x equals 60. And then all I need to do is divide both sides by 3 and end up with x equals 20. Next, all three angles are x. I already know the answer is x is going to be 60. How did I know that? Because it's equiangular. X, and x, they're all equal. They must be 60. But let's say you didn't remember that. Here would be the work to get there. Well, all three angles must add up to 180. X plus x, hey, that's 3x. Divide both sides by 3, and you got x equals 60. So it might be in your benefit to remember that trick that if all three angles are equal in a triangle, they must be 60. Once again, I have an exterior angle problem. Now remember, it's the outside angle equals. So outside angle is 94. That equals the sum of the other two angles. So remember, x doesn't always go on the outside. The outside angle goes on the outside. The outside angle goes on the outside. So with this one, I'm going to start off by subtracting 60 from both sides. And it'll leave me with 34 equals 2x. And then all I need to do is divide by 2, and I'm done. So you get x equals 17 there. Next one. Interior angle sum problem again. Now, since this one is a little more complicated, I'm once again going to color code it just so you can see. Now, it doesn't matter if you do red plus green plus blue or blue plus red plus green. It doesn't matter. I'm just going to start off as using the one angle plus the next angle plus the last angle. The interior angles of a triangle will always add up to, out of space, I'm going to write it down here, 180. Now this looks like a big scary problem, but it's not. We can combine our like terms. We got 3x, 2x, and x. That'll give me 6x. I can combine my constants. Okay, I've got the -17. I've got the -5. I've got the +40, which if I combine them together, I'll get 18. Subtract 18 from both sides. I'll be left with 6x equals 162. Divide both sides by 6, and you'll get, I'm out of space, I'll write my answer here, x equals 27.